Hello, my name is Micaiah Perkins, and this is my pseudocode presentation for the EEL 2161 project. So to start off, my pseudocode for choice B, the multiplication of two matrices, I start off with a do while loop that prompts the user for the rows and columns in matrix A, and then the rows and columns of matrix B. It then simply reads those rows and columns, and then goes into an if statement. So if the columns of A do not equal the rows of columns B, then they get the error message and it prompts for the new values. Because the if statement is nested in that do while loop, I have automatic reprompt, and it'll simply go through the loop again. And then we go into building matrix A. So I have a nested for loop. So we start by initializing our I variable to 0. And then for I less than whatever input for rows A, self counting. And then it goes same exact setup for our J variable, initialized to 0, J less than columns A, self-updating, and then nestled in that second for loop is the user prompt for elements that will self-update as well. Then after the loop completes for the prompt of elements, it simply reads and initializes that matrix. Same thing for matrix B, using variables X and Y, and then rows B and columns B. It has that nestled for loop, so for loop 1, for loop 2, and then that user prompt for the elements, and then simply initializes and reads that matrix. Next, we have outputting the matrices. So we start with a simple print statement, and then we have two non-nestled for loops this time. The same for loop setup as previous, and then it prints a singular line as is required by the sample output we were provided. Same thing for J, but instead of printing that sample line, it prints that matrix and a white space, and then we end that for loop, and then we have another print statement with that simple line to box in that matrix as is customary. Same setup for matrix B, using variables A and B, and then we do the setting up of that resulting matrix. So matrix C is the bounds of rows A and then calls B, and we can thus save our calculation into that matrix. So another two nestled for loops. We have I initialized to 0 and J initialized to 0 as we've done previously, but this time in that second for loop, we have initialized our sum to equal 0 so we can update it. And then we nestle a third for loop that includes the new variable k, and k is used to update the sum with the data from matrix A multiplied by matrix B. This is where my matrix calculation multiplication comes in. And then that statement simply ends with matrix C being updated as that sum that we computed. And then to output the final product, we have a simple print statement. And then for I equals 0, same setup as before. And then the pseudocode from the Copilot, which is the AI I've decided to use, we have simple prompts for matrix A and B, and then if statements that handle the dimensional mismatch, and then simply declaration of matrix A via rows and B, and matrix C is declared at this portion for this code. And then very similar for loops to what I've done. I have just taken certain liberties to write out it in more in depth for my own thought process. And then to end off the pseudocode from Copilot, for we have the same for loop, but we, instead of introducing that sum variable, the Copilot does everything directly on that C matrix. And then to print the resulting matrix, it's the same. To compare and contrast these two, my code allows for looping of the input validation, whereas the AI code does not. It immediately exits the program. The AI code runs the matrix input in a more succinct way, but does not allude to the proper formatting. And then my code does the resulting matrix via data storage and manual calculation, while the AI code uses that triple for loop. And then my pseudocode took liberties with not writing things out completely or writing things more in depth, whereas the AI pseudocode is consistent throughout. So my pseudocode for part D I have that same nestled 2 for loops throughout, exact same setup as before, except this time for matrix A, I specify a 3 by 3, so there's no input validation. And then for matrix B, I read the matrix as an x by 0 matrix since it is a 1 by 3. After that, I compute the determinant of matrix A, so I call the user-defined function that calculates that, which will be at the end of the code. And then I have a simple if determinant A equals 0, print no solutions, because if the determinant is 0, there are no solutions to the set of equations. After that, I create the matrix with variables. So matrix A becomes matrix AX, all 3 by 3. And then that nestled for loop, this time I've hard-coded the boundaries since I know these have to be 3 by 3 matrices. So our bounds are going to be 0 to 2. I then take those variable matrix and update them with the info from our regular matrix A. I do the same thing for the columns, except this time I only worry about the, I take the variable matrices and input the columns from the matrix B. To finish it off, I call the user-defined function for each variable, calculate the determinant, and then I simply use Cramer's rule, so determinant AX over determinant A for all my variables, and then my output is a simple print statement. And then for my user-defined function, I've yet to name it, but it is simply the determinant formula that I did not want to write out in this case, but I will in my real script, and then it simply returns that determinant value. The Copilot pseudocode for part D is similar. It prompts the user for matrix A and matrix B, as is mine. It then declares those matrices and then does the nested for loop with the same boundaries I had. And then for the function of determinant, it returns a float and then it declares that determinant and then it goes into that determinant calculation that I did not write out. And it simply returns that determinant just as mine does. It then declares the determinant of the variable matrices, and then it declares those, and then it uses the nested for loop to update them the same way I did. So first it updates those variables with the info from matrix A, and then it does the columns from matrix B, and then it simply calls that user-defined function once more to update and calculate, and then same with the declaration statement and the print solution. To compare and contrast these two, overall, my pseudocode is slightly messier than the AI pseudocode. However, they both still function. The AI pseudocode shortens variable names, which makes it easier to read. My code calculates determinant in a row column almost thinking way, while the AI pseudocode does a triple nested for loop pattern. And the outputs are functionally the same for both codes. My code, once again, just takes liberties with shortening the written parts or writing things out more in depth according to what I feel like I will need when I write my scripts. So which code do I prefer? Overall, I prefer my code as it incorporates my thought processes and is therefore easier to read and understand. However, when I write my full script, I may borrow parts from the AI pseudocode, particularly the shortening of those variables, the triple for loop nesting for the determinant, and I may also double check my code against this code just to ensure that all of my for loops are nestled correctly. So overall, I'll be using my pseudocode with certain inspirations taken from the AI pseudocode. So that is my presentation.